welcome back to my channel. In this video, we're going to discuss about the valid parentheses. Let's look at the problem statement. Initially, we are given with a string s, it consisting of the characters this, and we have to determine whether the given string is valid or not. And in order to check whether the given string is valid or not, the given string should satisfy all these type of statements. And let's look at the first statement. The open brackets must be closed by the same type of brackets. Like if I say, if I have this bracket, then it should must be closed with the same type of bracket. And let the same thing applies to this. Got it? Then let's go with the second statement. And the second statement gives the open brackets must be closed in the correct order. Like for example, if I have a open bracket like this, and it should be closed by the same close bracket of same kind, and also in the same order. Like it should not be closed by this, and it should be also closed by this. It should be closed by the same type of bracket, and it should be in the correct order. Like one closed bracket should be accompanied with the same type of opening bracket. This is mean by the correct order. Got it? And let's look at the third statement, which goes like every closed bracket has the corresponding open bracket of the same type, which is the same thing. Like if I have this kind of closing bracket, and I should have the same kind of opening bracket. Got it? And let's quickly see the example. Now see, I have the open parenthesis and also closed parenthesis. This closed parenthesis is accompanied with the same opening parenthesis. Then yeah, done. Because there is no another kind of opening or closing like this, like this, or like this, or something other statements. Therefore I can say that this is a valid string, because every opening have their respective closing and both are of same kind. And let's look at the another example. Here if we see this from if we see the support of the string, I opened it and I closed it, and both are of same kind. Done. In the same way, I opened this and I closed it, and both are of same kind. Done. And the same thing with this, I opened and closed it, and both are of similar kind. Therefore I can say that it is a true, like the valid string. And if we see the another example, which is somewhat interesting, I opened this, like open parenthesis and open square bracket and close the one. Yeah, here the problem arises. Like whenever if we see the third statement, which states that every closed one should accompany the same type of open one. And if we see here I am closing the parenthesis, and I should be accompanied with the same kind of open parenthesis. Like if I am closed one, yeah, this is the open parenthesis. This should be the correct order. But what happened here is I am accompanied with the square bracket, but I require the parenthesis, right? Therefore I have to return false. And yeah, this is the thing that we have to keep in mind. Like every closing one, like either parenthesis or curly or square, it should be accompanied with the same opening one. This is the the most important thing that we have to keep in our mind. And let's quickly see another example, like where it makes more sense to us. Like if I have some opening brackets like this, 1 2 3 4, yeah. Now let's see, I have one open, and here I found one closing one. Yeah, if I found a closing one which is a square bracket, then I should see the immediate left one. And yeah, for this the opening one is this, and do I found it here? Yes. Therefore this is the valid pair, and I have to continue this same thing for every character present in the string. Same with this, yeah, I found a same thing that here. Therefore I have to remove both. And for same for all of this, I found a respective pair and have to At the end, I left with an empty string, right? Therefore, I have to return true because it follows all three constraints that are listed. Okay, let's understand this further more. Like from the previous example, if we can take, I'm starting checking from this particular element because it's the closing one. But in order to look the left part of this specific element, I need to store this part, right? Yeah, and also I should get the one that has been recently added because at index 0 I might add this, and at 1 2 3 4 I add all this part, right? Yeah, this thing. But in order to check this, like for this closing I need an opening, right? Therefore in order to check, I require one data structure which gives me the element that is has been added recently, right? And this signals me something like using a LeetCode approach, which is last in first out. Therefore this is the one that has been added recently. Therefore I need this, which signals me a last in first out, which results me in using of this data structure called stack. And let's quickly simulate this approach with this given example. And yeah, I have the stack initially, and I start from iterating from 0. If I found an opening pair, I should append it to the stack, and if I found a closing pair, then I have to check with the the latest one, and if they are matched, okay, we have to move further, or else we're gonna then and there we have to return false. Got it? Yeah, let's simulate this. Here at index 0 I found an opening bracket. Okay, no problem, I have to put. And at index 2 I again found an opening pair. Therefore I should continue this process until and unless I found an close bracket. Got it? Therefore this is my stack looks like, and when I found this closing pair, I should look at this stack, like the top of the stack. Yeah, for this the expected opening is this. Yeah, is this the top of the stack? I need to check. Yeah, it does the top of the stack. Therefore we have to do one thing. I have to pop the top of the stack, like I have to remove it and also move it further. Now it's an closing one. For this the expected opening one is this. Does it present in the top of the stack? Yeah, it does. Therefore pop it and move further. For this the opening one is this. Okay, and again I found it in the top of the stack. Sorry, I missed one closing bracket here. Yeah, therefore I pop it, and we have to do the same thing with the remaining rest because it's a simple example, right? Yeah, for this the respected opening is this, and again it's the top of the stack, pop. For this the respected opening also same thing, and again it's the top of the stack. And when we hit the end of the string, we are left with the empty stack, right? Because all elements are popped out. Therefore we have to return, does the stack is empty. If the stack is empty, like I write if stack is empty, or you can say that if you can check this by two ways. In like if the length of the stack is 0, then I can return return true, or else I can return false. Like whenever I found an extra opening pair here, it would be something like this. I have one extra opening pair here, and my stack becomes one element, like it still contains one element and doesn't have any closing pair, like right, this thing. Therefore in that case my length of the stack becomes not equal to 0, right? It have length as 1. Therefore this thing will be executed and our result will be false, which is as expected. And let's quickly write down the code for this approach. Initially I need the data structure stack, and also I need a map data structure which uses to tell me for a particular closing what should be its expected opening. For the curly close, this is the expected opening, and same thing for this clear one. And I have to iterate in the given string for, let's say, character in S, I need to check if it is opening, like if character in like either a parenthesis or a flower or a square, right? If it is in opening, then just I do one thing is to append it to the stack dot append char. Else it must be a closing one, right? Yeah. This is the interesting thing that I have to discuss further. Like what if our string starts with a closing one like this? Yeah, this is our given string. In this way, when I look at want to look at in the stack, it must be empty because there is no opening here, like there is no opening pair, right? Therefore the stack must be empty, right? So in order to do this, I have to check first is the stack is present or not, like if it is have any elements. This can be done by if stack. Yeah, if stack. Else if there is no stack and I enter in the else box, then this is the case that is being said. Therefore if I have a closing without an opening, it makes no sense. Therefore I have to return false here. And yeah, done. Therefore yeah, I have to handle the case where there is a stack, right? And if stack dot pop, like the top of the stack, if it is equal to the map of char, which is the respected opening of that closing, right? Got it? Yeah, if it is equal, then pass. I don't want to do anything else. Or else let me write this in more simpler way. Yeah, got it. Therefore else if the stack dot pop is equal to map of that respected opening, sorry, respected closing, it pass, I will pass it. Or else I have to just return false. Got it? Yeah, let's simulate this way. Like I have an opening here. Yeah, we are going iterating over s. If char in opening, yeah, I have an opening. Therefore I gonna append it into the stack with this. And yeah, it's done with this. I'm gonna iterate further. Again opening, again wanna push into the stack. I found a closing here. Yeah, it enters into the else block. If there is a stack, yeah, the stack is it contains some elements, right? Therefore if stack dot pop, which is a opening square bracket, if it is equal to the map of char, and here for this the respected opening is this, right? It give my map of char will give this, and it checks with does this equal to this. Yeah, is it? No. It enters into the else block and returns false. And that's simple. And this is the code for this. And you can still eliminate most of the cases from this code. Like I can directly state that I can remove this else case, and also this thing stack of pop not equal to map of, then and there I have to return false. Yeah, we can optimize further this, but the ideology is totally same. And I have to check if stack, I have to return false, or else I have to return true, because whenever I found an element without any pair, like if I found an opening bracket without a closing bracket, yeah, this makes a violation of the given statements. Therefore I have to return false. And this is the thing that I had forgotten earlier. Yes. And let's quickly discuss the time and space complexity for this approach. For time complexity, let me analyze it further. This for loop takes a time complexity of order of n, where n is the length of the string. And if Karen, yeah, this also takes a order of 1. Appending it to the stack, it's amortized the order of 1. And yeah, checking the stack is constant. Stack dot pop, it's also order of 1. and everything is order of n. Therefore, the entire time complexity is order of n. And the space complexity here we use is the data structure, external data structure. Therefore, it's a order of n. Like when we have the case like if we are all opening, then we need to store all openings right into the stack. And the space complexity is also order of n. And if you found this video interesting, and if you understand everything, then please do like and share.